Okay, so welcome to today's video tutorial. Today we're going to be talking about how we go about adding a new feature. Well, I kind of lied. It's actually how do we go about debugging something and that turns into adding a new feature. If you've seen a recent video, we had a video where we were looking at this program called Workerd. It's from Cloudflare. I guess they're positioned as kind of like a Cloudflare workers that you can run at home. Runs islets, Wasm, and it's pretty cool. So let's go ahead and run it. We pop in here, and so if I just try to run it, it's crashing. Why? Because I don't have the latest greatest nanos. That's why. So if we scroll up a little bit, we can kind of see that there's actually some pretty helpful logs right here that tells us, otherwise we might, have to dig in and see what the instruction pointer is or, where all these frames are coming from. But this is pretty clear, like at least something got to, around here. So KJ, sometimes this takes a little bit of digging, but if you look at the source code, you'll eventually find that KJ is actually part of Captain Proto. So Captain Proto is Kenton's serialization RPC library. It's positions itself somewhere in between protobus and JSON, but better than both. And then inside of Captain Proto, you actually have this kind of, I don't want to call it a standard library, but like it's a set of libraries that are used, and so one of them is this thing called KJ. There was a README around here, but anyways, so why was it called KJ? This is an interesting tidbit. K and J are next to each other on your keyboard, which you probably know that. But that's in the QWERTY layout and the Dvorak layout. So that's something I didn't know. I never did pick up Dvorak, but I do have some friends that type in that. Anyways, this is kind of getting off base, but so we look at it and it says, okay, exception implementation, exception C++, line 634, SIG-alt stack. You trace this back, and essentially what it is it's failing right here. This isn't line 634, but this was, different. And what's going on here is that this is setting up a different stack to specifically handle things like seg faults. So, typically when you have a seg fault, one of the issues is like you might be, say, overflowing stack, but if you don't have enough space, then you're not going to be able to deal with it. And so that's what the purpose of this is that it sets up a new stack and it uses this called SIG-alt stack, and essentially you can track all these different signals that get sent now, and so like you can see right here, seg fault and seg bus and abort and all this good stuff. But to do that, it's a stack, right? The flag is called mmap grows down, and essentially what it does is it just pushes the stack down. It grows it because by default the stack isn't necessarily going to grow dynamically. It's a fixed size, but this basically allows it to grow by, quote, touching the neighboring page. Let's go ahead and see how this actually works in practice. So this was a test that I had ripped out of Nanos, and I've just lightly annotated it. But basically, color map grows down. And then we have this concept of the guard gap. And basically, this is 256 pages in size by default. You can change it. It's a tunable on Linux. And, page size of 4096 is, again, default. And that's just basically to prevent anything bad from happening. When you wouldn't want to grow into the heap, for instance, or you wouldn't want to grow into another mapping for instance, because very, very bad things can happen. So, Qualys had some sort of CVE, what was it, like 4 or 5 years ago, that was dealing with this sort of issue. Um, anyways, so we get our guard gap, and then we get our soft limit, which is one thing you should know about this is, and you'll see this is 8 meg. That sounds pretty high, but that's actually your virtual limit. So that's what's in the actual page table, not the actual physical limit. And so that gets set. Then we go ahead and call mmap again with our map grows down. We use the map length of our guard gap and the limit of the 8 meg, and then we set our initial stack size. This is just to deal with the difference between what might be in nanos versus not nanos for illustration purposes. We'll go ahead and unmap almost everything, but not all. And then we're going to create a thread. We're going to go ahead and set the initial stack size, which we calculated right here, to that thread, right? And then we're going to go ahead and call this map grows down function, and we're going to pass in the address on the guard gap. Now what this is doing is it's going to recursively call map grows down thread. And so you can kind of see where it looks at this built-in frame address, sees if it's greater than or equal to the stack limit page size divided by 2. Your built-in frame address, that's essentially just the return address of this function, and then it just recursively calls it. These up here, I just copied them in. They do exactly what you think they do, but it was just easier to call this in. All right, so now you can just kind of like run it. First, I'll show you so I mapped out the current soft limit, but then also I just wanted to show you how this is going down, as you can kind of see that. So yeah, this is not something that you probably would use day to day. In fact, some people have strong opinions about this. But it is something that you would find in something like this, in a library like that. And it's something that we did find in workerd, because Kenton works on workerd and he's over at Cloudflare, and he's one of the main authors of Captain, or I guess maybe the only author, I don't know, of Captain Protos. So anyways, kind of a long-winded journey, but that's how we found and implemented a new feature of map grows down. Till next time, bye.